Hello students, this video lecture is designed to help students of IGCSE Chemistry 0620. Today we are going to study how metals are extracted from their ores. What is an ore? Rocks from which metals are extracted are called ores. Rocks from which metals are extracted called ores. Example, bauxite, hematite. Bauxite, Al2O3, 2H2O, hematite, Fe2O3. These are ores. Bauxite is an ore of aluminium and hematite is an ore of iron. After mining an ore, the next step is to remove or extract the metal from it. How you do this? Extraction of metal depends on the metal's reactivity. In reactivity series of metals, potassium comes first, then sodium, calcium, magnesium, aluminium. Here we can place carbon and then zinc, iron, lead. Right? After zinc, iron and lead, we can place silver and gold. We can see potassium, sodium, calcium, magnesium and aluminium. These occur on the top of the reactivity series. It means these are highly reactive metals, or we can say it is not easy to decompose them. These are highly reactive metals, highly reactive. These are highly reactive metals and we cannot decompose them easily. Cannot decompose easily. But moderately reactive metals such as zinc, iron and lead. Zinc, iron and lead are moderately reactive metals and we can extract these metals by heating the ore with a reducing agent. For moderately reactive metals, we can extract the metal by heating the ore with a reducing agent. So we can reduce them. We can reduce them by using a reducing agent like carbon monoxide. But for silver and gold, there is no need of reduction or electrolysis because silver and gold are unreactive metals and they are present in their elemental form. So unreactive metals, in case of unreactive metals, there is no need to extraction as these are present in their elemental form or they are present in their pure form. So it means we can say the most unreactive metals such as silver and gold occur in their ores as elements. There is no need to separate the metal from sand and other impurities. This is like removing stones from soil. It does not involve chemical reaction. But for highly reactive metals, we have to perform electrolysis because we cannot decompose them easily. And for moderately reactive metal, we have to reduce them with the help of carbon or carbon monoxide. But for silver and gold, we don't need to extract them as these metals occur in their elemental form. So the ores of metals contain the metals as compound. Ores of metals occur in their oxide form or in the form of other compounds. They are in the form of like aluminium oxide, iron oxide, or they may be in the form of zinc sulfide, as zinc metal occur in their sulfide form. So what we do for the metal, those occur in their sulfide form like zinc blend. First we convert zinc blend into their oxide form, then we remove oxygen from their oxide and we can get the metal from it. It means we can obtain the metal from metal compound. Metal compound means ore after reduction. So it means we have to reduce the ore to get the metal. Reduction means loss of oxygen. It means when there is a loss of oxygen from hematite or iron 3 oxide, we can get iron, or when we can add 3 electrons in iron cation, we can get iron metal, right? Either way, the ore is reduced to the metal. The compounds of more reactive metals are very stable and need electrolysis to reduce them. We have already discussed it. This is a powerful method, but it costs a lot because it uses a lot of electricity. So for highly reactive metal, we need electrolysis, but electrolysis is a very powerful method and need, electricity. So it is very expensive. But the compounds of less reactive metals, we need a reducing agent. The compounds of the less reducing metals are less stable and can be reduced using a suitable reducing agent. Let's see this picture of reactivity series. So the method of extraction is strongly linked to the reactivity series as shown below. Carbon is included for reference. Here we can place carbon for reference because carbon is act as reducing agent. What carbon do? Carbon just displace the metal from their oxides. So potassium, sodium, calcium, magnesium, aluminium come on the top of the reactivity series. These are highly reactive metals and their ores are difficult to decompose. So we need electrolysis, and this method is more powerful and more expensive. But for zinc, iron, and lead, we can get the metal by heating the metal with a reducing agent such as carbon or carbon monoxide. But for unreactive metals like silver and gold, we don't need to perform electrolysis, or we don't need to reduce them as they occur in their elemental form. Carbon as a reducing agent. Carbon as a reducing agent. Let's see how carbon behaves as a reducing agent. How carbon behaves as a reducing agent. Carbon will react with oxides of metals less reactive than itself, reducing them to the metal. See, this is the reactivity series and carbon is present here. So what carbon do? Carbon displace the metal from their oxide, and we can get metal from it. The table shows that carbon can be used to extract zinc, iron, and lead. Carbon used to extract metal from zinc, iron, and lead. It is used in the form of coke. Carbon is used in the form of coke. And this coke is made from coal, and coke is heated with the metal oxide in a furnace. This coke is heated with metal oxide plus metal oxide. When we heat coke with metal oxide, we can get iron after reduction of metal oxide. But in this process, carbon reacts with limited supply of oxygen. Carbon reacts with limited supply of oxygen and gives carbon monoxide. Carbon plus limited oxygen, we can get carbon monoxide. And this carbon monoxide used as reducing agent. So carbon monoxide brings about the actual reduction. See, this is the picture of gold. No need to reduce gold because it occurs in elemental form. That's why our ornaments are made of gold and silver. We use gold and silver to make jewelry. 3 examples of ore extraction. 3 examples of ore extraction. Iron ore. Iron is mainly iron 3 oxide. Iron is mainly iron 3 oxide or hematite. It is reduced like this. Iron 3 oxide, when combines with carbon monoxide, it gives iron and carbon dioxide. Iron 3 oxide in solid state, when reacts with carbon monoxide, it gives iron, liquid iron, and carbon dioxide. And for aluminium ore, because aluminium is more reactive than carbon, we can see this in series. See, aluminium is placed above the carbon, so it is more reactive than carbon, so we cannot displace it by carbon, right? Or we cannot reduce its oxide with the help of carbon. So what we have to do, we have to perform electrolysis in case of aluminium. Aluminium is more reactive than carbon, so electrolysis is needed for this reduction. Aluminium oxide gives aluminium plus oxygen after electrolysis. What we have to do, we have to perform electrolysis. We cannot go for reduction, right? Because aluminium is more reactive than carbon. Aluminium is more reactive than carbon. After extraction, aluminium is made into rolls like this, ready for sale. What about zinc blend? Zinc occurs in the form of zinc sulfide as it is not present in their oxide form. So what we will do, because oxide ores can be reduced with the help of carbon, but if any metal is present in the form of their sulfide like zinc blend or zinc sulfide, first we have to roast it in air. It gives zinc oxide and sulfur dioxide. It gives zinc oxide and sulfur dioxide, right? And then this zinc oxide is reduced in one of these two ways, right? First, what we have to do, zinc sulfide when roasted with air, zinc sulfide when roasted with air, it means zinc sulfide is going to react with oxygen. It gives zinc oxide plus sulfur dioxide, right? This is the symbol equation. Zinc sulfide plus 3, zinc sulfide plus 3 moles of oxygen gives 2 moles of zinc oxide and 2 moles of sulfur dioxide gas. Now this oxide, this zinc oxide is reduced in one of these two ways. There are two ways to reduce this zinc oxide. First, in first method, what we do, we use carbon monoxide. And this is carried out in a furnace. Zinc oxide plus carbon monoxide gives zinc plus carbon dioxide. In a furnace, when zinc oxide is heated with carbon dioxide, it gives zinc and carbon dioxide gas. The final mixture contains zinc and slag of impurities. And this zinc is separated by fractional distillation. Fractional distillation is a method where we can separate the different components on the basis of their boiling point. Zinc boils at 907 degrees centigrade. And second method is electrolysis. For this, a compound must be melted. We know that in electrolysis, there are two ways. There are two ways to perform electrolysis. Either it should be melted or it should be in aqueous form. Right? It should be in aqueous form. Right? Electrolyte should be melted or in aqueous form to perform electrolysis. But zinc oxide is very, but the melting point of zinc oxide is very high. It is 1975 degrees centigrade. And this zinc oxide is insoluble in water. Right? So what we will do, we cannot melt it, or it is difficult to make its aqueous solution. So what we do, we dissolve it in dilute sulfuric acid. We dissolve this zinc oxide in dilute H2SO4, dilute sulfuric acid. And after dissolving this zinc oxide into dilute sulfuric acid, we can get zinc sulfate. We can get zinc sulfate. See, when zinc oxide dissolved with dilute sulfuric acid, we can obtain zinc sulfate. It is a salt. Zinc sulfate is a salt and water. So this zinc sulfate undergoes electrolysis and zinc is deposited at the cathode. And this zinc is scraped off the cathode and melted into bars to sale. In fact, most zinc is extracted by electrolysis because this gives zinc of very high purity. Cadmium and lead occur as impurities in the zinc blend, and these metals are recovered and sold. Thank you.